renaming this whole thing. It says we are live,
It says it, yep.
but we are still loading. Not fun.
Takes a
And
second.
there we are. Oops. There we go. All right. Hello, everyone. Welcome to the OpenHours podcast, episode one. I've been trying to sort of redo the whole OpenHours stuff as a podcast, and hopefully, this becomes the first officially live streamed um, episode for the new sort of look and feel we are giving to OpenHours. And yeah, hopefully I'll be able to upload this episode to wherever podcasts are available. And if you're on YouTube, you are already watching it. So welcome. I guess today I have with me David Tischler from Mini Nodes and Balena. And we are going to talk about some of the work we did with a few of our friends at ARM and other places uh, that work with ARM architecture on helping resolving the bit of the human malware issue we are having these days. And yeah, so how are you, David? What's going on?
I'm doing good. Um, Thanks for hosting. Do you want to give a little background of kind of where we got started, perhaps?
Yeah, so, well, I mean, you probably have a larger background on it, but for me, it was Rex from ARM, and then you, of course, contacted me about the ongoing efforts to get Rosetta on ARM ported to Rosetta at home ported to ARM64 architecture. And so a little bit of background of what Rosetta at home is. I'll
Yep.
drop in a link as well. So Rosetta at home is a project hosted by the University of Washington,
Yep.
and
Yep.
it's a distributive computing project that runs on the Boeing platform. Now, if all of that seems confusing, I suggest searching Boeing and distributive computing and grid computing. Basically, it means if a normal consumer has like some hardware, some computer hardware that's spare or mostly idle, they can donate their spare cycles to scientific research. And Boeing is one of the platforms that enable it. And Rosetta at Home are much like folding at home, doing molecular simulation for proteins, and in this case, the COVID-19 protein and all of the medicines and different chemical combinations that might be able to solve the issue. And what it's basically is they simulate the different proteins within the virus itself at like nanoseconds scale, um, and they simulate their movement to see if there's a bit of a gap and a bit of a area where they can target a particular chemical composition in form of a medicine that will attack it and essentially destroy the virus itself. So so that's sort of the idea, and we wanted to help. We had a bunch of ARM machines laying around. I actually had made a cluster a while back with all the spare ARM machines I had to donate to Boeing basically. And I wasn't running Rosetta. I really wanted to, but they didn't support ARM64 at that point. So back to where Rex got in contact with me. They were already talking with the team at Rosetta, and basically we got together and we were able to port ARM over, which was luckily for us a very small patch. Since they already supported a lot of architecture like PowerPC, so it wasn't very Intel specific, but still for the time it was a very easy patch, but it just required a bunch of testing over and over again just to make sure that the um, results were sane and usable. So yeah.
Yeah, no, I think that's the perfect summary, Sahaj. I mean, from my perspective, I was vaguely familiar with these distributed computing projects like Folding at Home, SETI at Home, Einstein at Home, et cetera, et cetera. And when I started seeing some of this pop up in my news feeds and social media of, using Folding at Home or Rosetta at Home to, fight COVID-19, I thought, okay, hang on a minute. I know obviously that big, powerful GPUs are gonna, do the real heavy lifting. But I mean, I've got probably a dozen single board computers around the house doing essentially nothing. I want to contribute. Let me fire them all up and see if they can get some work done as well. And so I pretty quickly found out that no, they are not enabled by the Rosetta or Folding at Home projects. So I thought, okay, well, just like everything else in the ARM universe, time to build from source. So, I went looking on GitHub for the Rosetta at Home project. I was going to just do a simple git clone and start the porting process. Turns out, we did have to actually reach out to the University of Washington to get that source code. It is publicly available. You just have to kind of know where to look and jump through a couple of hoops. But once we gained access to that source, like Sahaj mentioned, it's pretty simple porting effort, all things considered. And then from there, it was working with the University of Washington to ensure that the scientific results being generated were in fact valid. So there's a verification process they need to go through to ensure that the simulations coming back to them from the worker nodes are actually accurate. So Rosetta has a staging area by the name of Ralph, which is just simply Rosetta Alpha. So that's their beta testing platform. And it's not that they don't advertise it per se, but it's not in the default list of options in BOINC. So you just simply add that project. And once they had taken our patches and enabled them or ported them into the Ralph system, we were able to attach to Ralph through BOINC and start actually processing work units. And so that's what they used then to verify the results coming back. And I don't know, what do you think, Sahaj? It was probably about a week or so that they validated the results before then pushing it to Rosetta.
Yeah, so I think it happened a lot in layers, where initially we were just testing the binaries itself, and then there was some very, very basic tests that were inbuilt in the source code. So we were running those, sending those up with like um, different parameters, and then I think they built one on their own. They built the binaries on their own, and just to cross check that it worked properly, they sent us their binaries. So we tested that, and then followed by a couple of weeks of waiting time till they set up their servers. Sorry, a couple of days, and then we were on Ralph for about a week.
Yep.
And we honestly we dried up their servers really quick, and I'll get to that. Who helped us, and with what kind of horsepower do you dry up a cluster compute server? So it's kind of coming to that. I'm sharing 3 links here. These are the 3 blogs. One of them is by me. I'm dropping it in YouTube as well. Wait, yeah, copying from Zoom always messes it up. Nope, that does not look right on YouTube. Nope, again. Oh god. Wait a minute. So that's mine. On Zoom, it just comes out fine.
Yeah. Do you need to do them one at a time on
Yeah.
YouTube?
That's David's, and the last one is by Neocortex. Um, so talking about the team, it was basically me, David, and a couple of folks from Neocortex. And Neocortex um, basically a startup. I'm not sure if they're a startup, but they are basically a
Yeah.
company that uh, has a lot of different products, but one of the things that they do is have like a container running inside of Android, and this was sort of their target use case was to run Boeing inside a Linux GNU container running inside of an Android device, and so I and David were testing on native boards, like natively running stuff on ARM and testing like that, whereas Neocortex did the cross-compile patches and some of the Docker builds as well. So I'll just share my screen for a second just to glance over all of the different there you go, all of the different blogs. So hopefully everyone can see this. And this was my blog, just a bit of a personal uh, touch to it. And so I just basically just mentioned everyone who was involved and everything else. But here you can see that the way we drained out all of the Ralph jobs that were given were basically Ed Wilmity from Works on ARM, aka Packet, gave us a huge 64 core ARM 64 monster. It's at the I don't know if it's okay to name it, so we just call it Unobtainium everywhere we
Mhm.
go. So it's a
Mhm.
64 core ARM machine. It's probably okay to call its name, but we don't. So, anyways, and apart from that, we also had two more Ampere Emacs. Those were 32 core each. Actually, one of them had enough RAM in it that we were able to run the entire Rosetta project out of RAMFS just for lols and just so that the hard SSDs wouldn't get as much hammered. Um, so yeah, bunch of memory on all of those machines. So that's how you end up draining out the their jobs, their work units. And then I had a bunch of other devices, including David's soft iron AMD Seattle that he donated a while back. This was sort of the main development platform I used throughout this project, just because it had like 16 gigs of RAM, and that just makes it much easier to not be concerned about restrictive memory. Talking about which, right now the situation is as such that anything less than 2 gigabytes is a bit iffy. Even 2 gigabytes is iffy. If you have 3 gigabytes or more of memory, it's perfect, but you really need, I think it's like zero point 0.6 per core plus some additional memory for the OS to run. So even so, like my high key 970 has 6 gigs of RAM and 8 core that only can run 7 jobs at a time, whereas my AMD Seattle has 16 gigs and 8 cores, and that can run 8 jobs at a time comfortably. So yeah, it's a bit of a memory hog.
Yeah.
So yeah, um, and so this image was the first sort of proof of concept that it works. This is not this is a simulation sort of a thing, not really a proper job, but like the first test we ran. This is sort of an image of my homebrew ARM cluster setup. The AMD Seattle, just a close-up shot of that. And here are the 64 cores from the Unobtainium machine, and then the two Emacs with 32 core each. So if you can see the top output, yeah, it's a lot of horsepower there. Um, and here is David's blog, which actually goes into details of about setting up on your Raspberry Pi 4 because it needs the Ubuntu build because only 64-bit targets are supported. So you need the 64-bit Ubuntu build. And then you go, and David also goes into the NVIDIA Jetson setup. So again, it's a CPU only task, so you won't be using the CUDA cores on the Jetson, but just for the time being, it works fine and it's getting jobs regularly, so that's okay.
Yeah. Well, it's
Uh,
worth. Oh, sorry, Sahaj. It's worth noting though that Rosetta is optimized for CPU algorithm or CPU mathematical computations anyway. So the Rosetta project does not actually make use of a GPU even on the x86
yeah,
platforms, I don't believe. Correct me if
no,
I'm
it
wrong.
doesn't. Yeah, yeah, it
Right.
doesn't.
So,
Yeah, so a bunch of codes you can run it on, and then Neocortex also had a very well written blog about
mhm.
their point of view. They did explain a lot of the stuff very well with diagrams and stuff. So yeah, those were the blogs. But what I do want to get into is the amazing work that people have done about sharing it over Twitter and on YouTube. Especially Gary explains it all, um, and a couple more YouTubers. ETA Prime also did one, and we have a Crunch on ARM team on Rosetta, and we now have 92 total members from like 87 just this morning. So we are growing pretty well, and this like I think just about a week. I think we already crossed teraflop, was it?
Yeah,
Yeah,
I just saw that this morning when I woke up. Blue, BLU from Twitter had
yeah.
posted that. He's keeping watch on the total compute.
Yeah, so these are just the people who have joined our team. But apart from that, I have a counter. If you go over at Twitter, twitter.com/shajsarup, I post regular updates on this every day. But I have a counter running on a Pi Zero on an e display. And so it goes through. So they have a large 3+ gigabyte XML file. So I have it set up to like go through the entire XML file every day and count all the instances that say ARM as P vendor, and it shows. So this disregards the Android targets. So I just wanted to count how many devices that we had enabled. So all the Linux ARM platform, and it counts 303 right now, with right about on the very edge 2 million credits in total for all the ARM 64 devices. So it's pretty awesome.
Yep.
And yeah, so good work, everyone. Just keep crunching
Yeah.
and join the Crunch on ARM team as well. So if you have any questions, the blogs are your best place to get answers, because we've explained how to set it up. David has done a good job. And again, you can find me on IRC as Rick96, on Twitter at SHJSARUP. My name's right there, just all small, at place an at symbol in front of it. Um, and yeah, any closing words?
No, not for me. I think we covered it really well.
Yeah. Oh, actually, no. I had one more thing to screen share. So let's see. I have Boink TUI set up to show everyone. So let's see, Boink TUI. So right now, some of the boards I have that are less than 2 gigs or just 2 gigs are not running Rosetta, but I have, let this load. I have the RB3. Again, it's running 4 out of 8 uh, jobs available, and just because of the RAM limit, RB3 is a 4 gig device. So you can see the WMEM uh, error here, which is not an error, which is just waiting for memory. So
Yeah.
that's fine. It will crunch through that. I have the Hikey 970, which is running 5 jobs in total. So it's also running a couple of jobs less than the full 8 core capability. Again, one of them is waiting for memory. And I have the AMD Seattle, which is running all 8 jobs at as much capacity as it can. So this thing's like
Yeah.
really, really crunching through, and it makes up for like a lot of the credits that.
Yeah, I think it's such an awesome platform. Such a such a shame it
Yeah,
was not more successful.
yeah, I know. Oh well, but yeah. So I guess that's now about it on my end
Yep.
as well.
Cool. So he is
So
crunching away over there.
also, again, thank you everyone for joining. First episode, just keeping it short about the recording time. You can always join us on Zoom. The link to the call is, yep, that's the correct link in the description. You can move over. So every day we all join at 4 p.m. UTC on Zoom, and then we do. I am planning to do like a small bit of recorded or live stream part, and then put that over the podcast area. So that's sort of because I really needed to hit a bit of community interaction, because it was just usually me talking all of the time or one of the other guests talking, and the entire audience was just quite like there right now. But but yeah, so we shut this down, and then we talk a bit more, and then we all go our merry ways and do our work from home things that we do. Again, thank you so much. Do join us next time, uh, Thursdays 4 p.m. UTC, and yeah, thanks everyone. Bye. And